Hello friends, myself Mahajan presenting my video on MCQs for inverse Laplace transform part 1. Example number 1, inverse Laplace of 1 by s is equals to. We know that Laplace of 1 is 1 by s, and therefore transferring this to other side we get inverse Laplace of 1 by s as 1 as the correct option or the answer for that first problem. It is option B. Example number 2, inverse Laplace of 1 upon s minus a is equals to. Find the correct option. We know that Laplace of e raised to at as 1 upon s minus a with condition s greater than a, then transferring this operator to other side. Therefore, we get inverse Laplace of 1 upon s minus a as e raised to at as the answer. Option C is the correct option. Example number 3, find the value of inverse Laplace of 1 upon s square plus a square. Find the correct option out of that 4, and to find it, we Laplace of sine at as a divided by s square plus a square. Then transferring this operator to other side, we get therefore inverse Laplace of 1 upon s square plus a square. That constant we keep on that side only, and therefore transferring that a to this side, we get 1 by a sine of at as the required answer, and option C is the correct option. Example number 4, find inverse Laplace of s divided by s square plus a square, and to find the correct option, we know that Laplace of cos of at as s divided by s square plus a square, and then transferring this to other side, we get therefore inverse Laplace of s upon s square plus a square as cos of at as the answer. B is the correct option. Fifth example, find inverse Laplace of 1 upon s square minus a square with the condition s greater than a. And to find the correct option, we know that Laplace transform of sine h at as a divided by s square minus a square with the condition s greater than a, and therefore transferring this to other side, we get inverse Laplace of 1 upon s square minus a square as, transferring this to other side, we get 1 by a sine h at as the answer, which is option D. Example number 6, find inverse Laplace of s divided by s square minus a square with the condition s greater than a. And to find the answer or correct option, we know that Laplace of cos hyperbolic at as s upon s square minus a square with the condition s greater than a. And then transferring this to other side, we get therefore inverse Laplace of s upon s square minus a square as cos HAT as the answer. Option B is the correct option. Example number 7. Find inverse Laplace of 1 by ss to n where n is not a positive integer. And to find, we know that Laplace of t raised to n plus 1 divided by ss to n plus 1. Transferring this operator to other side, we get therefore inverse Laplace. But while transferring it, we consider instead of n plus 1 as n only, and therefore inverse of 1 by ss to n means I am subtracting 1 from n throughout this step, and therefore we get here it is t raised to n minus 1 divided by gamma n plus 1 minus 1 means we get gamma n as the answer. Option A as the example number 8. If n is positive integer, given condition that it is positive integer, then inverse of 1 by ss to n is equals to, we know that Laplace of t raised to n as gamma n plus 1 divided by ss to n plus 1, and as per the property of that gamma function, if n is positive integer, the value of that gamma n plus 1 is n factorial divided by ss to n plus 1, and therefore transferring this to other side and subtracting 1 from n everywhere, we get inverse Laplace of 1 by ss to n is equals to, transferring this to other side, we get t raised to n minus 1 divided by n minus 1 factorial as the, it is option C as the correct. Example number 9. Find inverse Laplace of 1 by s cube. Find the correct option out of that 4. And for that, we know that here that n is a positive integer. Laplace transform of t raised to n as n factorial divided by ss to n plus 1. If n is positive integer, as n is positive integer, and therefore transferring this to other side, we get inverse Laplace of 1 by ss to n as, just we obtain that result as example number 8. It is t raised to n minus 1 divided by n minus 1 factorial, and therefore we get inverse Laplace of 1 by s cube, substituting n as 3. Therefore here it is t raised to 3 minus 1, we get square divided by 2 factorial, or 3 minus 1 as 2 factorial as the answer. Option C is the correct option. Example number 10, last example. Find inverse Laplace of 1 upon s raised to 3 by 2. That power n is not positive integer here, and to find that inverse Laplace, we take the help of that standard result. We know that inverse Laplace of 1 by s raised to n, if it is not positive integer, it is t raised to n minus 1 divided by gamma n. And therefore, applying this result, inverse of 1 by s raised to 3 by 2 as t raised to 3 by 2 minus 1 divided by gamma of 3 by 2 as the answer. Or we can rewrite this as it is t raised to 3 by 2 minus 1, we get 1 by 2. Gamma 3 by 2 we can rewrite as gamma n plus 1 in that form as gamma 1 by 2 plus 1. And applying the standard result, we get t raised to 1 by 2. Gamma n plus 1 is n gamma n, and therefore it is 1 by 2 gamma 1 by 2. And we know the value of gamma 1 by 2, it is root pi, and therefore it is t raised to 1 by 2 upon 1 by 2, that goes to numerator, therefore it is 2 divided by gamma 1 by 2 is root pi as the answer. Option A as the correct option. Option A is the correct option. In my next video, I will discuss some more examples from inverse Laplace transform. Therefore, if you are watching my videos, please like and share it, as well as subscribe to my channel to get updates for new videos or latest updates. Thank you. Thank you very much.